Okay, so what we're going to be talking about today is we're going to be doing the phases of the moon, mainly. There's a few other things I'm going to throw in there, but yeah, we're going to be doing the phases of the moon. And to help us do that, we're going to be using this figure that I put up on Canvas. Essentially, let's just get into it, okay? Let's just get into it. First up, what we're going to be doing is over here, this is sort of a space view of what's going on. Like if you were floating way away from the Earth, looking down on the North Pole of the Earth, this is what would be happening right here. Over here, we're going to be drawing what each moon phase looks like if you were standing on the Earth looking up at the moon. So it's like our view. That's what you normally see. And then down here, I left a space, and I went ahead and filled it in with some letters right here. On the bottom, we're going to put in the names of each phase, okay? So, first up, here we go. Let's figure out what everything is. Right here, we got the Earth. And over here, I've got a few arrows that say sunlight. And that's to tell us that way off that side of the page, so way over there somewhere, like a mile that way, is the sun. Okay, so the sun is always behind those sunlight arrows. It's sending that sunlight in. Okay, so if this is the Earth and the sun's way over here, what are all of these 8 things right here? What are all of these? What's that thing? What do we got going here? Yeah, that's the moon, okay? And so I'm not saying that there are 8 moons. What I'm trying to show here is the moon orbiting around the Earth. So we're looking roughly straight down on the North Pole of the Earth, and the moon orbits roughly around our equator. Everything's a little tilted. We'll talk more about that in a later section. But it orbits roughly around our equator, and that's why if you're looking down on the pole, you can see the moon orbiting like this, okay? And so this is just pinpointing 8 different locations on the orbit of the moon, okay? Now, don't overthink this. Don't overthink this. From our point of view out here in space, how much of the moon is lit up at any given time? How much of the moon is lit up? In every single one of these. Half. That's right. It's exactly half, okay? So it's exactly half. And the reason that this side is lit up, all of these moons look identical from space, but they're going to look different from the Earth's point of view because the Earth's not looking down on everything like we are right now, okay? So each one of these look identical. Why is it that every single one of them has this side lit up? Why does every single one of them have this side lit up right here? Might have to check that out. It's pretty simple, right? It's facing the sun, right? That's the side that's the side of the moon that is facing the sun. So the moonlight we see is not actually made by the moon. As you probably know, it's actually reflected sunlight. So whichever half of the moon is actually facing the sun is going to be lit up at any given time. Okay, let's add some stuff. Let's ignore the moon for a second, okay? Let's just look at the Earth itself, okay? How much of the Earth should be lit up at any given time? How much of the Earth should be lit up? Pretty simple question as well, right? It's also half, right? And just like the moon, the side of the Earth that's facing the sun should be lit up. So here's the first thing we're going to add to this picture. Let's draw a straight line across the Earth, okay? And that straight line is going to represent the edge of the shadow on the Earth. There's a technical term for the edge of the shadow, or the edge of the shadow of any shadow, and that's the terminator, okay? Spelled just like You know, the Arnold Schwarzenegger dude, right? The Terminator is the edge of the shadow. It's like where the light is terminated, right? So let's shade this in right here. Okay. All right. So exactly. Half of the Earth is, I'm reacting, for any of you watching this on YouTube later, I'm reacting to memes right now. Okay. Anyway, check this out. We also need to indicate the direction that the Earth rotates in this picture, okay? Because we're looking down on the North Pole, and that means it could either be spinning like this, or it could be spinning like this, right? So we need to know which way it's spinning in this picture. And an easy thing to remember is that the Earth spins, or the Earth rotates, in the same direction that the moon orbits us. So in this picture, because the moon is orbiting us counterclockwise, that means the Earth is also spinning counterclockwise, right? Yeah. So that means I'm going to add a couple of arrows to indicate the direction of the spin of the Earth, but I want to put them in a very specific place because there's other stuff we're going to have to add in here. So I'm going to put an arrow right here, pointing that way, and another arrow for the Earth right here, kind of in the corners of that Earth picture. So that's just indicating that it's spinning like this. And I don't want to make those too big because, again, there's some more stuff we need to put on here. Okay, now, here's why I asked you to have a copy of this. Check this out. Let's just ignore the moon. Just look at the Earth, okay? I'm going to spin this page so that the sun is way up here at the top, okay? We're going to just focus on the Earth and the sun, okay? Now, here's a quick question. If you are right here, if you were standing on the Earth right there, and this is going to be a bit of an easy question here, can you see the sun? Can you see the sun if you're standing right here? And don't worry, if you forgot to print out the figure, you could always fill your figure in later, okay? Now, technically, check this out. It's night there, right? How do I know it's night if you're standing right here on the Earth? I'm in the shadow, right? I'm in the shadow. I'm in the shadowed part of the Earth. If the sun is up here and you're standing back here, the Earth is in the way of your view of the sun, right? So it's nighttime when you're down there, okay? So you can't actually see the sun down here because the Earth is blocking your view of it, okay? In order to see the sun, you got to stand on this side of the Earth, okay? If you're standing on this side of the Earth, the sun would be above your head somewhere, okay? If you're down here, it's nighttime, okay? So, that means where you stand on the Earth determines what time it is, okay? Where you stand on the Earth determines what time it is. And there's a few important times that we need to put into this figure, okay? And one of them is, what if you're standing right here, okay? If you're standing right there, where would you have to look in the sky to see the sun? Where would this person have to look to see the sun? Like, which direction would you point your head? Up. Straight up, okay? In fact, there's a name for straight up in astronomy. There's a fancy term for it. Let me flip this over so I can write it. The word for straight up is zenith. It's also pronounced zenith. Those are both okay ways to pronounce it, but zenith here, that's the word for straight up. So yeah, if you were standing right there, then you would have to look at your zenith or straight up to see the sun. Now, don't overthink this. What time would it be? What time would it be? Yes, somebody's saying Zenith is an old, yeah, it's an old electronics brand. Yes, they made some TVs, same name, Zenith. What time would it be, though, if the sun was straight over your head? Yeah, you guys are getting it. It would be noon, okay? So that means if you spun around the Earth, when you spun to right here, it's always going to be noon when you get to that spot. Everybody who's spun to that place is going to have noon happen. And that doesn't mean it's noon for everybody in the world. It's just noon for everybody at this place on the Earth, okay? And when they spin off of it, it'll be afternoon, right? Okay. Now, check this out. That means the people who are standing right here, who can't see the sun at all, and are exactly halfway through the night, what time would it be right here? What time should we put on this place on the Earth? And notice it's exactly 1/2 turn off of noon. Yeah, that would be midnight, okay? Okay, so noon and midnight. Noon over here, midnight over here. Sorry, it's a little small. I'm still trying to fit everything in here. Would we all have the same time zone if the sun was the same all over Earth? If everywhere you stood on the Earth there was a sun above your head, then yeah, we would all have the same time zone. That would be a very, very strange setup, but yeah, I guess that would be true. Yeah. Okay. Now, 2 last times we need to add into this. 2 last times we need to add in. One of them's right here. Okay. If we're right there, that's halfway between noon and midnight, which means it's going to be 6 o'clock. But we need to know if that's PM or AM. Is it PM or AM? Oh, yes, somebody just preempted that question. It is 6 p.m. How do we know it's PM and not AM? So I'm just going to put this right here, 6 p.m. How do we know it's 6 p.m. and not AM right there? Exactly. It's afternoon. If we look at the direction the Earth is spinning, if you were standing at noon, you'd get to this place afternoon. So it's going to be PM, right? And what, in this picture, on this particular day that I chose, what is the sun doing when you're standing roughly right here? What's the sun doing? Right here. Yeah, it's setting. The sun is setting roughly around that time. And yeah, because of the tilt of the Earth, sometimes that's a little bit before 6 p.m., sometimes it's after. So I don't want to just say sunset right here. I'm just going to say 6 p.m. But check this out. If you were spinning, remember the sun's up here, right? The sun's up there. So if you were spinning around the Earth, the reason the sun sets at around 6 p.m. is if you spun a little bit more, you'd be back here behind the Earth again. So the sun sets when you're spun back behind the Earth and the Earth gets in the way, okay? And so somebody actually pointed out, what time are we going to have over here? This is 6 a.m. There we go. And the sun is going to rise then because the Earth is going to get out of the way. If you spin from midnight to here, suddenly you'd be able to see stuff up here at around 6 a.m. So, these are going to be 4 important times, okay? Somebody's asking, how can weather stations give you times for more than a day out about the time the sun will rise and set? So because the Earth's tilt doesn't change in one given year, We always know it's basically geometry that those weather stations have to do. Okay, using geometry and using basically the shape of the Earth and the tilt of the Earth, you can tell exactly how much it will have moved into the sunlight every given day. So just basically complicated geometry. It's not so complicated that we can't do it, but if you wanted to, you could calculate what time the sun will rise on any day of the entire year for the rest of your life if you wanted to, and you would be reasonably accurate.